So today I have with me, I'm Shuenhwee, and today I have with me Leah, Raj, and Jiehui. So the three of them are like all undergraduates from NTU, and Jiehui and Leah have been working with us on our climate adaptive manufacturing project, developing a planter box, like a modular one. So they'll be first sharing more about their modular planter box in today's session. Then we would go into a short discussion with Raj from Garage at EEE to basically talk about how we can enable more, we can capitalize on the makers movement and kind of enable more students, especially to work on projects with us. And yeah, so Jiehui and Liao, do you all want to start with your presentation on the modular planter box? Yeah.
Okay. Hello everyone. So thank you for joining us today. Yeah, and I have been working on this planter box since the start of the year. And a bit of background about us, we are both mechanical engineering students, but this is actually our first venture into product design. So before we showcase our actual planter box, I wanted to take a step back and share with everyone our design process. So our initial design was actually inspired by the helical structure of a DNA, hence the theme Garden City DNA. We wanted to build a spiraling structure with the individual modules and use it to support crawlers, and this was more of an aesthetic piece. So unfortunately, circuit breaker happened and we had to work from home, and there was just no way we could fit that large helical structure in our tiny HDB flats. So we asked ourselves, how can we adapt our initial design to our current context while retaining the essence of the Garden City DNA theme? And at that point in time, Malaysia's MCO also got a lot of people panic buying food, including my own family. So this made me realize how fragile our supply chain is. And the thing is, it's not easy to grow food in our own homes. We have so little space. And while there are HDB gardens like these, it's often very cramped and messy and subject to HDB regulation. So we wanted our planter box to change this, and we want to encourage every household to grow their own food. And our planter box enables them to do so because it will complement the space that we have. So when we refreshed our design, we had three things in mind. So of course, it had to look pretty. And we also narrowed it to 3 different types of plants here that was more suited for HDB growing and more commonly eaten in Singapore. And most importantly, right, the structures we built from the modular unit has to be able to adapt to the HDB common spaces. So this is what we came up with. This is the modular unit, and when you have many different units together, you can actually have many different permutations of structures that fit nicely into the HDB space.
Okay, thank you, Jiehui. So now we're sharing more about the design aspect of this modular planter box. So first of all, our primary concern is its modular feature, as we want people to exercise their creativity and have fun while growing crops. So we hope that people can enjoy using this modular feature to build the different structures they desire. So our planter box can be joined in 3 different ways using the stick and hole mechanism, similar to the Lego style. So you can join the modules side by side using either the triangular face or the rectangular face, or even the rectangular face at the back. So in this way, in order to secure the entire structure, we also introduce a hook mechanism in which our design boat is linked to the 2 modules through the wall and will be secured with a cap. So our boat is also designed in a hexagonal shape to provide more stability compared to a regular cylindrical shaped boat. Next, we have also introduced a slab mechanism in which you can cover up the holes in the modules with the different slabs. So it's up to you where you want to put the slabs and how many slabs you want to use. So this allows you to vary the degree of light intensity for plants with differing needs. There are 2 kinds of slabs which you can use, one with holes and one without holes. So this is designed for the case when the module is inverted and needs drainage through the holes. So it can also be used to regulate light intensity. Lastly, we have a drainage system with holes at the back of each module. There is also a bottom support and a tray that comes with each module so they can collect water and prevent overwatering the plants. If we were to stack the modules vertically, water that drips down from the upper modules can also be recycled to the plants at the lower modules, promoting sustainability. Okay, so we have actually 3D printed a module, and this is how it actually looks like. So we have not settled on the material yet because in the future we may want to introduce a technological improvement in the material, such as using hydrogel to provide some self-watering functions. And one key aspect of our module is that we want to promote aesthetics together with functionality to achieve something with more irregular shapes, like the one in the slide. However, for now, our modules are not able to achieve big rotations while ensuring stability at the same time. And in the meantime, we are also unsure of the prototype production because currently we are facing a lot of difficulties with 3D printing, and there's a limitation on the size that we want to print. So hopefully we want to hear some suggestions to this panel on how we can improve this prototype. Yeah, so that's all we have got to share. Thank you for listening.
Yeah, thanks, Jia-hui and Leo. So I think a bit of background knowledge about climate adaptive manufacturing. It's basically a vision where we can move from like an extractive economy to a contributive or like a generative economy. So it's a sustainable approach to manufacturing that focuses on the principles of qualitative customization, localization, and minimization of carbon footprint. So under like this umbrella, we are interested in like working on collaboration projects with students and also actually anybody. Yeah, but I think Audacity also believes that students, the young people would be the catalyst of our movement. So we would like to collaborate a lot more on like projects like this with Leah and Jia-hui and with other students. So I also invited Raj from Garage to kind of join this panel so that we can have a short discussion on how like the notion of innovation with technology among students can be further developed. Yeah. So yeah, maybe Raj, you can start with a short introduction of Garage at EEE.
Hey, hello. Yeah, hello everyone. Yeah, so I'm Raj from Garage at Tripoli. Garage at Tripoli is a makerspace in the School of Tripoli, NTU. We are a makerspace that is run by students, for students, and all the initiatives that we do are fully student-run. From the planning to the execution, and even the post, pre and post is all done by students. We hope to empower students, to take ownership of their own learning and allow them to take a more hands-on approach to solving problems and doing projects itself. I would say that Garage at Tripoli, we are a makerspace, but at the end of the day, I would say we run more like, a tech organization. At the heart of what we do is very related to technology, training related, but we also have various other how do I put it, portfolios that help to tap on the various avenues and bring back opportunities to our students within the school itself. So we have a steering committee. A steering committee will lead 5 different portfolios. So we have portfolios like training and development. So training and development, as the name suggests, they are the ones that conduct all the training, passing of knowledge, in terms of technical stuff, the workshops, etc. Then we have startup development that also helps to allow students who have ideas, who want to, come up with a startups and they're not sure how to do it, they can always approach us and we can bridge the gap in that area. We have branding and marketing, which is very important in these days, how to brand our workshops, our events, what we do to the masses. We have business development. Business development is basically they go out, reach out to companies, bring back opportunities, to our students through the form of hackathons, competitions, or industrial workshops, so that it benefits our students. And lastly, operations, because at the end of the day, we are a makerspace, students come in to work on projects and then build stuff. So operations takes care of the makerspace on a day-to-day basis. So yeah, at the end of the day, we are a makerspace run entirely by students. I would say that one of the important things for us is that we try to bring technology and tech-related stuff, to the students within the School of Tripoli and to the College of Engineering in general. We have 2 flagship events every year. Yeah, every year we have 2 flagship events. I would say that Garage at Tripoli is one of the first makerspaces. In fact, should be the first makerspace that brought fun and engineering together. So, and that is in the sense through our 2 flagship events, Initio and Isendo. So, Initio is our freshman orientation camp. So you guys are at least university students, or you should know that when you do a freshman orientation camp, what you think of is usually cheering and a lot of other games, wet games, whatnot. But in initial, what we do is that we understand that students are a bit afraid. Sometimes they're a little afraid. They're not sure what to expect, as they enter the university phase. So what we do is that we try to inculcate fun, but bring engineering elements into our program as well. So we create games built entirely by our own students, escape room games, and these are all generally done over a period of year. Is planned by students, and then we execute it during the orientation itself. Our other event we have is we call the Essendo. Essendo is our winter makeathon camp. We call it winter because it occurs just before the start of the second semester. So it's a 3-day, 2-night camp where we not showcase to our students, we bring our students through 2 or 3 workshops, and then we ended up with a 12-hour themed makeathon. So just this year the theme was IoT Town. So basically they went through workshops on, I would say, Arduino, Raspberry Pi, and then the theme was IoT Town. So we give them different scenarios, and they're supposed to use the skills that they've learned to build a prototype over 12 hours. So in this way, what we do is that we are trying to teach skills, do events, bring knowledge to students, so that they can implement this and start working on bigger projects, and empowering them to take care, of their own learning, do more projects, and improve the skill level generally of our students in the School of Tripoli.
Yeah, that's really cool initiatives that Garage at EE has. And I think it kind of lowers the barriers by making it more fun to be involved in this kind of technical projects. So I was wondering if this kind the participation in these events, is it very organic coming from the students, or are they or do you have to kind of force whereby you have to do a lot of publicity? And
I think participation, thank you. Participation, I think in general, we do get a fair number of participants every year. In fact, this year for Essendo that I just talked about, we even opened it up to the College of Engineering. So the pool of students, I would say, we get is quite a lot. But we still have to do a bit of publicity at the same time, because I think for such events, especially when it comes to students, they are very a lot of students are very focused, on academic stuff, curriculum-wise. So it's always a bit hard, for them to think out of the curriculum. It's just a mindset thing. So whenever we do any workshops, we do any events, we try to do a fair bit of publicity. We do get the numbers, but we always try to aim higher and higher, because we think that, by bringing students from different backgrounds together, by bringing them, from various disciplines, it will help one another to get viewpoints on one another, how different disciplines solve problems. And I know it contributes towards a more holistic problem-solving method.
What about Jie-Hui or Liao? How would you describe your peers' comfort levels on kind of being involved in this kind of makers culture, and then therefore working on projects and innovation?
I think that among engineering students, even though we are already engineering students, the comfort level is still not very high. I think people still have the stereotype that there's this very steep learning curve to learn to start doing, or you need to get a certificate to get start doing using 3D printer or using other softwares. So I think since it's already very high, the comfort level is really very low in engineering students, it may be worse among general students. So it's quite worrying. Yeah.
I think to add on, right, maker culture at the end of the day is an extension of the DIY movement. But I would say that DIY is actually pretty common among students, and it's getting a lot more popular. I have so many friends buying sewing machines and trying to make their own jewelry or decorations. But it just seems like when it comes to 3D printing something, it feels like a whole different ballgame, and it's something only for engineering students, and you require a high level of technical expertise. But the truth is, actually, sewing is just as difficult to master as 3D printing. So I'm really curious why why there is this mindset around how makers movement is only limited to people in tech.
Yeah, true. I think as with COVID now also, we see that like it's really much more important for students to build up on their skill sets and maybe like in a certain way the technical capabilities to be able to come up with more innovations or solutions that will actually allow like our communities to be more decentralized and supply chains to be more localized. So I think you guys raised a point whereby like the kind of movement here is very technical, and there's a mental barrier where people don't feel that comfortable adopting technology. So I was would you guys have any inputs on how we can, like what kinds of systemic shifts would be needed to kind of encourage more students from different backgrounds to overcome this mental barrier, like even outside the engineering school?
Okay. Yeah, maybe okay, I'll answer that question first. Yeah, I think systemic shifts, like I mentioned just now, yeah, first systemic, one of the shifts that we need is shift in the mindset and attitude of our students. But at the same time, I think while you're trying to change the mindset of the students, what is more important is that maker spaces, maker events, should do more publicity and branding in the sense. I think that is equally important as well. I mean, if you want to change mindset, it's easy to talk around, but really we have to publicize and tell them why. Why is it important in the first place? I mean, we talk about COVID. I mean, COVID-19 is rapidly showing us that in the future is going to be rapid digitalization. The winners that are coming out of COVID-19 are those who have embraced technology. So in the future, I think we can only experience more of this stuff, more technology-related stuff. It's even more important that students start learning this various skill sets, start adopting this mindset of problem solving, working on projects so that they can build bigger stuff. But then again, for them to even get there first, I think one of the first things we have to do is that maker spaces, like for example, like Garage at Tripoli, we have to always focus on doing more marketing, more branding, telling students why, for example, this workshop, say Arduino or Raspberry Pi, why is it important in the first place? Must tell them, this is important for prototyping. If you want to prototype, you want to build something, these are one of the first steps that you have to take. Then once you tell them why, I think then they will start to realize that, oh, I need this in the future. I can see where you're coming from. Then they can come on board as well. So firstly, I think it's also, it has to be branding to a certain extent, telling people why we do. Having a space is not enough, but showcasing what you do is important as well. Second thing I would say is that to reduce the barrier entry, I would like to just point to the fact that, for example, our initial that I mentioned to you just now, our freshman rotation camp, involving fun to what you do is a very good way of getting students to come on board, this maker spirit as well. Because I think the people, like Shuenhwee mentioned, that why do they think that this is only restricted to engineering students? So I think at the end of the day, if you take out the barrier that that this is by inculcating fun, you are showing them that it's very interesting. You can build many more stuff, based on what you learn. I think it's really going to get more people to come on board. People have this mindset that it's very boring. It's the maker spaces are very boring. It's for nerdy people. It's for and just for entrepreneurs. They don't understand that this space is actually for everyone. And I think by including fun in what we do, that will really get a lot of these young people to come on board as well.
So I have a question following Jiehhui and Raj's comment. Like, how do you think we can make it fun? Because I think there are quite a lot of workshops available to kind of make the knowledge accessible. But then that there's still that mental barrier whereby like I don't like it's available. It's like the prerequisites are you don't need to know anything, but then people are still not attending. So how do you think we can actually make it fun or like rebrand maker spaces? Yeah.
I think it's definitely to do with the things that a makerspace is associated with. So before this whole project, I always thought, okay, makerspace is for people to build robots. But what use do I have for a robot other than to hone my engineering skills as an engineering student? But after this project, I realized that actually a lot of the things that I use at home can be made with these maker skills. Like I can 3D print I can design a rack on Fusion and see how I want it to look like. And I think perhaps the answer lies in trying to localize the products you make in these maker sessions to be more household usable items. So for example, it can be even things like so for example, recently with the COVID mask shortage, there are a lot of people 3D printing 3D printing the mask hooks. So I think if we can make the maker sessions more focused on making things that you use every day, people will start to see that these skills are not limited only to people who build robots, but it is important for everyone to know and be able to build the things that you need at home.
Okay, just to add on, I think that Singapore is a very practical society. So like with everything they do, they kind of want a certain reward associated with it. So I feel that the best way to inculcate this kind of maker spirit is through school education, and maybe should include more hands-on modules in school. So for what I know, there is this O-level course, like it's quite old, called TNT, which teaches a lot about hands-on building things. But MOE made it an optional course, so a lot of people just don't want to take this course because they're scared that they may not be able to handle it, may not be able to get A for it. So I think maybe it would be good to have more compulsory courses like this for students to make them realize that it's important to have hands-on skills, especially in the future economy. So yeah, I think you should start from students for now.
Sorry, I was muted. Yeah. So I think there's an interesting comment from Brian. He said like the two factors: why make something myself if I can pay someone to do it, and the fear of failure can be a big hurdle for people to take on such projects. I think, yeah. Do you have anything to like respond to this comment? On like, Raj, would you like to take this question? Like, how do people overcome this kind of hurdle?
Oh, okay, sure. I think that's a very good point actually. The fear of failure actually stops people from even joining in the first place. I think the solution to such cases would be to is to allow a support system to be established within the projects itself. For example, if I would just give you an example that we had in Garage at Tripoli. I think sometimes whenever we get onto doing some projects, while the students are doing projects, obviously they fail from time to time, but we always put a senior who is more experienced, who has done many projects before, has been successful. We attach a senior to this group who will always guide them along in case they fail, who's always there to encourage them and tell them how to navigate the various pitfalls that they may fall along the way. I think failure will be bound to happen. I think we must accept that there must be room for failure whenever we do technical projects. But I think a way to solve them would always be to establish a support system. I think whenever you have a support system, people will be more comfortable, they'll be more willing to share their experiences, and in that way, whenever they fail, they won't be afraid to try again and get going on, because with the experience they're getting and also the companionship that they have. Yeah.
Okay, it's 4:27, so I guess we kind of have to wrap up this discussion. Yeah, does anybody have any final comments to make with respect to like how students can be, how we can get more in collaborators among students? If not, then I guess I'll hand the time over to Project Share. So Project Share envisions a sustainable human-centric future community enabled by innovation. It is a joint initiative by Ecolab Center of Innovation for Energy and Mistletoe to bring about a change in the design of future cities with the concept of sharing and resource efficiency. Yeah, so Chachian and Ritika will be sharing more with us about the realities of living off-grid. And thank you, Raj, Leah, and Jiahui for your time. Yeah, so please do stay on if you want to join Project Share session. Thank you.